Hi everyone, welcome back. Today we're going to be doing Unit 8, Lesson 5. This lesson is analyzing data sets using mean and MAD. So before we get started, just go ahead and make sure you have all the materials you need again today. Same materials as for your last lesson. You're going to need a paper, a notebook to take notes, your classwork on Google Classroom, a pencil, and then you're definitely going to need a calculator today. Remember that you can use a calculator online also. Make sure your note-taking tool is set up the way this piece of paper is. You should have the date. It should say Unit 8, Lesson 5, and then you want to title it Analyzing Data with Mean and MAD. Go ahead and take 30 seconds to set that up. Okay. Before we move forward, we want to make sure that we review what we discussed yesterday. So yesterday we were talking about mean absolute deviation, or MAD, and remember that MAD is a measure of the average distance of each data point from the average of all data points. We also talked about why it's important and how it can help us analyze data, and so remember that the smaller the MAD, when the data is closer together, there is less variability and an increase in consistency. And then the larger the MAD, when the data is more spread out, there's an increase in variability and a decrease in consistency. And remember that to calculate the MAD, we first take the average of all of the values, then we find the distance from the average of each of the data points, and then the last step is we take the average of those distances. Okay, so this is just a quick overview for you. So today we're going to be talking about why mean and MAD are actually helpful. Okay, and so when you're comparing large amounts of data, you want to be able to compare and analyze the data more holistically, but also more efficiently. Mean and MAD provide us with important information about a given data set that allows us to draw conclusions and make comparisons more easily than we would without it. So let's take an example here. Something that you might consider when you're deciding where to go to college is whether or how high earning your job would be after you graduate. So a lot of universities, after their students graduate and get their first job, they track what amount of money they're making for their salaries their first year upon graduating college and getting their first job. And so let's just take an example here. Let's say you had University A and University B, and you've just randomly selected 8 students. And here you have listed their salary upon graduation for their first job they got after college. This is their yearly salary. So looking at this information, it's kind of overwhelming. This is only 8 kids, but imagine you had way more kids having just graduated that university. There's not much I can tell just from looking at these numbers. Now though, let's go ahead and analyze that data, and let's say that we took the mean or average of each data set and we also calculated the MAD, which you see here. So for University A, the mean or average salary was $72,375 and the MAD was $9,850. And then for University B, the mean or average was $65,387.50 and the MAD was $5,234.38. So just looking at this data now, you're going to go ahead, your teacher's going to pause this video and you're going to look at this data and answer the following question, which is question 1. If you were interested in getting a job with the highest possible salary after college, which university, A or B, would you choose and why? Your teacher's going to go ahead and pause this video and you're going to enter your response. Okay, let's review. You might have chosen A, you might have chosen B. There actually isn't a correct answer to this question. It really depends. Both universities offer different strengths, and we're going to talk a little bit about those right now. So if you look at the 2 averages or means, University A does have a higher mean salary for students for their first jobs after college. You can see that University A has a mean of around 72,000, whereas University B is around 65,000. So University A does have a larger average salary. However, even though the salary at University B is lower, it's not by a huge amount, and the MAD for University B is actually smaller. And that tells us that there's more consistency and reliability in the scholars' salaries post-college at University B than there is at University A. And so that's also a worthwhile consideration. You can see now, though, how important it is to have these data points like mean and MAD to be able to compare data, because imagine you had been looking through thousands and thousands of data points to try and decide which was the better college. This helps you make an informed decision really quickly by using really important information. So let's talk about when to use each. If you're interested in a measure of center or a value that's representative of a data set, you're going to use mean. Remember that that's the average of all your data points, and that's going to help you for any measure of center. If you're interested in a measure of variability, though, or you're interested in how consistent the data is, you're going to use MAD, because MAD is a measure of variability. Remember that the smaller the MAD, like we already mentioned, the smaller the variability, and the larger the MAD, the larger the variability. Okay, so now you're going to practice. Here is the problem. I'm going to read it out loud. Lewis is comparing the average monthly temperatures in two cities that he's considering moving to, City B and City C. The temperatures are shown in the table below. If Lewis wants to live in a city that has diverse temperatures throughout the year, where should he live? So this is your second question. I want you thinking, which do you think is the better data analysis measure here? Are you interested in mean or MAD, and why? Your teacher's going to pause the video and you're going to go ahead and enter your response in Google Classroom. Okay, and in this case, you should have gotten that MAD is the better data analysis measure, because Lewis is interested in diverse temperatures, which means he wants there to be variability in the temperatures over the year. And we know that MAD is a measure of variability. All right, so now you're going to actually figure out where he should move. So this is your third question, which is which city should Lewis move to? You want to use your MAD calculations to support your reasoning. This is going to take a little bit longer, so your teacher's going to go ahead and pause the video, and you're going to have about 2 to 3 minutes to work on this on your own to determine which city he should move to. All right, and let's review the correct work. So here you can see the MAD calculations for City B and for City A. For both cities, actually, the average was 63. However, when you calculated the MAD for City B, you should have gotten 5 3/10 repeating. And when you calculate the MAD for City C, you should have gotten 9 and 8.3 repeating. Now, comparing these two values, you can see that Lewis should move to City C because it has the larger MAD, indicating the temperatures there are more variable or diverse, which is what he was interested in. Okay, let's move on to the second example. This is your second problem. The dot plots below show the distance swam by swimmers in the Olympics during the semi-final and final round. For which round did the swimmers swim a longer distance overall? So this is question 4. I want you to think, which do you think is the better data analysis measure here? Is it mean or MAD, and why? And you're going to go ahead and enter your response in Google Classroom. Your teacher's going to pause the video now so you have time to answer. And in this case, the correct answer was mean. Mean is the better analysis measure because the average will allow us to quickly determine for which round the distance was longer. It's a point that's super representative of each of the data sets. Okay, so now you're going to go ahead and actually calculate that out. So you want to determine which round had an average longer distance, and this is question 5. For which round did the swimmers swim a longer distance overall? Your teacher's going to pause the video. Once again, this is going to take a little bit longer, and you're going to go ahead and calculate out the averages for each of the rounds and compare. You're going to have about 2 to 3 minutes to complete this task in Google Classrooms now. Okay, and let's review the correct work. Here you can see the average calculation for the semifinal round and then also the final round. Notice that for data points where there were 2 of the same value, I just multiplied that by the number of times that data point was represented in the dot plot. However, you still have to divide by the total number of dots. So in this case, it was 8 for each round, okay? When you calculate out the averages, you should have gotten 53 and 3/10 for the semifinal round. And then for the final round, you should have gotten 53.1875. And on average, in comparing those, you can see that swimmers swam a longer distance in the semifinal round than they did in the final, as can be seen by comparing those two averages. Okay, and so all of this practice really culminates in our key point for today, which you want to make sure you have written down in your notes. The mean and MAD help us draw conclusions about data by describing the center and variability. Make sure you have that down in your notes. And for independent practice, you're going to be working on your classwork problems 1 through 6, and then you're going to have an exit ticket with one problem that has multiple parts. Really what you're practicing today is knowing when to use mean and when to use MAD to analyze data, and then also making sure you're really, really comfortable with those calculations and can easily calculate both the mean and MAD for data sets. Good luck, and you're going to go ahead and end this video now and get to your classwork.